Glass is everywhere. Windows, phone screens, drinking glasses, car windshields. It looks almost invisible. But here's the strange part. Glass is made from sand. And sand isn't transparent at all. So how does something cloudy and rough become something clear enough to see through? The answer lies in heat, chemistry, and the way light behaves. At its core, glass begins with sand. More specifically, sand that's rich in a material called silica or silicon dioxide. Silica is one of the most common materials on Earth. It's found in rocks, quartz, and beaches all over the world. But sand grains are tiny crystals. And crystals don't usually look transparent in piles. So what changes? Heat. A lot of heat. To make glass, silica sand is heated to extremely high temperatures, over 1,700 degrees Celsius. At that heat, something important happens. The rigid crystal structure of the sand breaks down. In solid sand, atoms are arranged in an organized, repeating pattern. But when melted, that structure collapses into a random arrangement. When the molten material cools, it doesn't reform into crystals. Instead, it becomes something called an amorphous solid. That means the atoms are locked in place, but without the regular crystal pattern. And this disorder is the key to transparency. To understand this, think about ice. A single crystal of ice can be clear, but crushed ice looks white. Why? Because light scatters when it hits boundaries between tiny crystals. Sand is made of countless small crystalline grains. Light hits each grain and bounces around in different directions. That scattering makes sand look opaque. But in glass, there are no crystal boundaries. Light can pass through with far less scattering. And that's what makes it transparent. Pure silica glass is difficult to work with. So manufacturers add other materials like soda ash and limestone. These lower the melting temperature and make the glass stronger and more durable. Modern glass is carefully engineered for different purposes: window glass, tempered safety glass, bullet-resistant glass, and fiber optics all start with the same basic principle and control how light moves through the material. Transparency really comes down to light behavior. When light hits most solids, it gets reflected, absorbed, or scattered, but glass is special. Its atomic structure allows visible light waves to pass through without being absorbed. The energy levels inside glass don't interact strongly with visible light, so the light keeps moving. That's why glass can be clear, but still block other types of light, like ultraviolet, depending on how it's made. Not all glass is crystal clear. Impurities in sand like iron can give glass a greenish tint. That's why some older windows look slightly green. Manufacturers remove or balance these impurities to create ultra-clear glass for things like smartphone screens, high-end windows, and scientific instruments. Even tiny changes in composition can affect clarity. You may have heard that glass is a slow-moving liquid. That's actually a myth. Glass is a solid, just not a crystalline one. It doesn't flow at room temperature. The reason old windows sometimes appear thicker at the bottom is due to old manufacturing methods. It's not because the glass moved over time. Another example of how myths stick around longer than facts. Humans have been making glass for over 4,000 years. Ancient Egyptians created glass beads and ornaments. The Romans developed early window glass. Today, glass is essential for skyscrapers, space telescopes, internet cables, and solar panels. All because we learned how to control heat and atomic structure. Glass seems simple, but it's actually one of the most remarkable materials ever engineered. It's made from sand, transformed by extreme heat, structured in a way that lets light pass almost undisturbed. Next time you look through a window, you're not just seeing outside. You're seeing the result of controlled chaos at the atomic level. Sand turned invisible.